convolutional neural network click predictor. We are upgrading it to support batches, so we can submit all of our data to the accelerator and one blast, which is, necessary in order to gain some of the benefits of accelerating the performance of the training process, making it faster. So we are just about there. We got started earlier today. We're doing part 2 of this. We should be able to finish the batching of that today. So that way we should be able to, what I want to do is submit the batches to the accelerator, get the results back, and then maybe paint one of the output examples. So as you saw, if you've seen previously, we've got a very neat looking rendered graphic that shows the current prediction of the click based on previous clicks as the output, and also sort of a heat map from previous clicks. So we're going to keep that. We just want to do the submission batch. Also, we're only doing one epoch, and we're not doing any shuffling of the data. So those are 2 extra things that I need to write down. We need to do shuffling. Okay, so batching, more than one epoch, and shuffling. Shuffling data. Shuffling, shuffling. Okay, so we want to do these things. So that is the plan. I don't know if we'll get to the training multiple epochs, or if we'll get to the shuffling part. So we will find out. We'll find out. We'll see what we get to. That's the output is going to be output this. All right, so we want this. We're going to use torch.stack. I'm going to say output. wait. Output and out. Okay, so out. I think output and out like this. I think we have to do it like this. And there's also a dims equals 0, which I believe is the default. And we don't need that. I'm pretty sure we don't need that. Okay. Now it goes, I'm pretty sure it goes batch with height and then channel. I need to double check that. I do believe that should do the trick, and then we just return output because we're storing the stack. It's a tensor, which is empty, and then it goes over here, and it should work as a batch. So we should be able to keep the same dimensions as before. I'm pretty sure. All right, so let's see. I want to say print. I want features size. I want to print the size. Features size. Is it called features.size? Something like that. Can we do that? I'm pretty sure we can do that. Let's see if it works. Okay. Let's try it. All right. Maybe. Okay. XY0 index 2 is out of bounds. Image. Okay. So image. There we go. Got to do it like that. There we go. I'm pretty sure that's correct. Okay. So now we should not have an out of bounds anymore. Hey, all right. Oh, well, just kidding. There's always something. There's going to be something. There's going to be something to go here. Okay. So argument tensor position 1 must be a tuple of tensors, not tensor. What? Oh, is it on the stack? Okay. Must be tuple of tensors. Okay. Well, then that's just like this. Or just like that. All right. All right. There you go. That's weird. Is it still angry? Okay. Stack expects each tensor to be equal size. Oh. 0 and okay. We can do that. We can make that happen. What is a good way to make that happen? Because we're just trying to concatenate and append onto for each one. I suppose. How's it, guys? Doing some Pytorch. That's what we're doing now. Torch.cat a comma b, and that's going to say tuple. You want to need tuple. All right, so we'll do a tuple. Tuple. There we go. Let's clear that. Okay, so that merged them. It merged them. Okay, so that concatenated. I don't want to do that. I want stack. So that is exactly what I'm looking for. I want to stack it. However, what we could do, I got it. Okay, I see what we got to do now. All right. The output needs to be torch.stack. Torch, return torch.stack. And then we are going to have a tuple called outputs. Like that. Outputs. And we'll say outputs. And the tuple, so say C equals like that. We'll say A comma B like that, right? And then so you say torch.stack. So this is going to be outputs dot append. So we do outputs here. Let me double check this. Output. We are going to be output here. Outputs dot append. I'm pretty sure tuples still do that. So this will be image. I'm pretty sure. Is that good? Yeah. All right. So this will generate pixels. Or click positions on the canvas. So we're painting the click positions on the canvas right here in this loop. And this is all the batch. So we're encoding over the batches here. Put that there. I think it's fine. And then for that picture, we append it to the outputs. And then we return stack outputs. Is this going to work, you guys? I don't know. Let's find out. Okay, where is it going to crash this time? Tuple object has no attribute append. Well, we need to append to a tuple. Python. A equals tuple. Let's just say 1 comma like that. So it's a tuple. A dot push. A dot. Tuples are immutable, right? Synthesis. Yeah. Tuple like that. Can we say 1, 2, 3? Will that convert it to a tuple? It does. This is ridiculous, Python. Okay. That, and then we're going to say like this, and we'll say tuple. There. Now we're good. Now we fixed the tuple problem. So we should be, is it finally? Okay. Calculated padded input size per channel, 1 by 1, kernel 5 by 5. Kernel size can't be greater than actual input size. Right. Okay. I remember we hit this problem previously. Maybe let's drop this down. Maybe need bigger image. Okay, good. All right, good. That fixed that. All right. We're on our way. We're on our way. Cannot be multiplied. Okay, so we need a new. It needs to be 384. 384. Instead of 1056. All right. 1056. No. First, 1056. There we go. 384, I believe. All right. So I think that's the new answer. Tuples are immutable. You would need to concat a tuple, then unpack it again. Yes. So we had to do some weird. We're okay. It's not like it's a lot of code. So we just have a normal list. We're concatenating and appending to the list. And then we're converting it to a tuple, which is what TensorFlow requires in order to make a tensor, the output tensor, the correct shape, I think. Let's double check. Let's double check that we did that right. Stack. Okay. So what do we call this? Images. Do we have this word yet? No. Okay. Equals this. And I want to print that. Oops. Oopsie. There we go. Let's say like this, and then we'll say print images. Perfect. Okay. So I want to see what this looks like. Should be fine. Size. I'm pretty sure we can do that. And then we return images. So I want to print that. Let's see here real quick. Wait, got to put a comma. Obviously syntax. Okay. What did it say? What did it say? Oh, whoa. Hey, there we go. And there we go. Look at that. All right, you guys. All right. I don't know what happened, but magically it started working. It magically started working. We're good now. All right. So does that mean we win? Does it mean we win? Obviously, it's not batches. It's not batches, but it's working without errors now. This is great. We've got input length, and that would be one batch. That's one batch. So if we wanted to do multiple batches, we need to... All right, so predictor, AI is marker, AI marker point, list, clicks, number of coordinates. So this works, and it's a batch size of 1 currently. Although when we're submitting it, we need to then collect all the previous clicks and then submit it as batches. And I want multiple epochs, and we should do shuffling. I think we need to do that, and that should give a better model output. So I got to